Hi everyone, welcome back again to Mathematics for Engineering 3, International Program เกษตรศาสตร์ University. Today is the third clip of the fifth chapter, which is our last chapter. It's the series solutions to differential equations. Okay, and today is the solution near an ordinary point. Okay, so in this video, we are going to actually solve the equations. Okay, before this it was the introduction, right? I told you what is the chapter is going to be about, and then in the next in the second video I told you the differences between the ordinary points and the singular points, right? If you remember, the ordinary points are the points that b2x isn't zero, right? It's not zero. If it's zero, it's going to be the singular point. Okay, and in this video we're going to be looking at the solutions near the ordinary points. Okay, so let's begin here. The solution near an ordinary point, we have two subsections. The first section will be when we look around an ordinary point x equals 0, and that is the first case. When we are looking at x equals 0 and it is an ordinary point. Okay, and the theorem says that if x equals 0 is an ordinary point, this is important, it's very specific. Okay, first it needs to be ordinary point, and second is x equals 0. Okay, so it say that 0 is an ordinary point. So if x is an ordinary point and is 0, we can say that the solution of this equation, which is the one that we are interested in, right, can be written in terms of this power series. This is very important. Okay, it says that our solution can be written as this power series. Okay, when a n are constants, blah blah blah. Okay, these are like a mathematical details. Okay, and as engineers we don't care much about those. You should, but it's not the main topic. Okay, we're not gonna be asking like what is the the convergence interval or those kind of thing. We're gonna just ask you to solve the differential equations. Okay, so let's first look at an example. Okay guys, I haven't told you anything yet, right? I just told you one thing. It is that if you want to find the solution near an ordinary point, which is x equals 0, you can be sure that the solution can be written in terms of this power series. Okay, and the first example, they ask you to find the solution around x equals 0 of the equation y double prime plus y xy prime plus y equals 0. So first you need to make sure that x equals 0 is an ordinary point. Okay, is it? And from the previous video we know that it is, right? An ordinary point right now our b2x is 1, right? Because it's 1 y double prime. Make sense? b2x is the coefficient of y double prime, right? So it's 1, so it can't be 0. So any points would be ordinary points. Okay, no singular points. Okay, from previous video if you remember. Okay, so all the points are ordinary points, which means that x equals 0 is also an ordinary point. Okay, and that is verified. Okay, so right now we know that we want to find the solution around x equals 0, which is an ordinary point. So we are sure that y can be written as a power series which is summation n from 0 to infinity an x to the n. Okay, that is the first step. Okay, because x equals 0 is an ordinary point, so you are sure, okay, you are confident to say that the solution y can be written in this form. Good. After that, what you need to do is that you need to find y prime and y double prime so that you can substitute all those into this equation. Okay, let me call this equation star. Okay, so we will find y prime and y double prime, and then we will substitute all y prime and y double prime into the equation star. Okay, so what is y prime? Y prime would be, guys, when I say y prime, I mean dy by dx. Okay, because right now our dependent variable is y and the independent variable is x. Okay, as you can see, we have one x here. Okay, so y prime means dy by dx. So if you want to differentiate y with respect to x, so you need to differentiate that summation, right? And guys, you know that this is actually a0 x to the 0 plus a1 x to the 1 plus a2 x to the 2 plus a3 x to the 3 plus blah blah blah, right? And if you want to differentiate, you differentiate it by x to the whole y. You can differentiate it term by term, right? Because the derivative of x, a plus b is the derivative of a plus the derivative of b. So you can differentiate it term by term. Okay, so you know that y prime would be summation n from 0 to infinity. An is just a constant, right? No x in there. And then we get x to the n. So in that case, we get n x to the n minus 1. Okay, so I can write it again as summation n from 0 to infinity n x to the n minus 1. Okay, and then if you want to find y double prime, that will be quite easy as well, right? You just need to differentiate y prime, right? You need to differentiate this guy another time, right? So y double prime would be summation n from 0 to infinity. There's no minus here. 0 to infinity, and then you get n minus 1, right? You get n, and then n minus 1 an x to the n minus 2. Why? Because if you differentiate x to the n minus 1, you get n minus 1 x to the n minus 2, right? And this n minus 1 is here. Good. So right now we get y prime and y double prime. Okay, and then next we are going to substitute y prime and y double prime in equation star. Okay, so what we have would be, what is it? What would it be? It would be summation n from 0 to infinity n minus 1 an x to the n minus 2, and then plus that is y double prime, right? Let me highlight it here. This is y double prime. Okay, which is this guy. Okay, and then we have x, which is x there, and x, let me highlight it as pink. Okay, and then we have y prime. What is y prime? Y prime would be summation n from 0 to infinity n x to the n minus 1. Let me use the yellow here. Okay, and then you need to plus y, which is summation n from 0 to infinity an x to the n. That is nothing but y. And these guys equals 0. Okay, the sum of those guys is just 0. Good, good. Okay. Next, I'll look at each term. I'll look at each term. For example, the first term, what would it be? Just rearrange and write it again, okay? It will be summation n from 0 to infinity n minus 1 an x to the n minus 2 plus summation n from 0 to infinity n x to the n plus summation n from 0 to infinity an x to the n equals 0. Okay, here I push x here in there, so x to the n minus 1 would be x to the n. Good. X times x to the n minus 1, you will get x to the n. Cool. After this, you can see that, we want to make these three summations, to one summation. We need to, to group them together into just one summation. But as you can see here, the problem is here. You have x to the n minus 2. You have x to the n. And you have x to the n. That's the problem. Okay, we have different exponents, right? We get n minus 2, n, and n. So what we can do is that we can rearrange, we can reindex the summation to make the exponents the same. For example, if I take this one down, okay, if I just want to look at this summation, okay, summation n from 0 to infinity n an x to the n minus 2. Okay, if I want to write this summation as, x to the n, my bad. If I want to write this summation as n as x to the n minus 2, what should I do? Okay, basically, I want to change from x to the n to x to the n minus 2. What would I do? What should I do? Of course, here, the first term is when n equals 0, right? And then n equals 1, n equals 2, and blah, 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 right? Right? That means the first x would be x to the 0, x to the 1, x to the 2, right? It would be 0, a0, x to the 0, plus 1, a1, x to the 1, plus 2, a2, x to the 2, plus blah, blah, blah. Okay, so if you want the right hand side to be exactly the same as the left hand side, you just need to start from n equals, what is it? What should you start from? You should start from 2. Okay, if you start n from 2, x to the n minus 2, that will be x to the 0. Make sense? It's going to be x to the 0. Okay, and here that will be n minus 2 and a n minus 2. Okay, it's actually, if you look at this property, it's actually the fourth property. Okay, an x to the n, you look here, x to the n, x to the n minus k. You can change x to the n to x to the n minus k, but you need to change n from 0 to n from k. See, n need to start from k, and then you substitute all the n with n minus k. Okay, so just to make it easy, if you want to change from x to the n to x to the n minus k for any k, for example, x to the n minus 2, summation n from 0, you need to change summation n from k. Okay, and any n you change to n minus k. Good. For example, this one, I can do it more easily. By just use the property. Say summation, I want to change to x to the n minus 2, right? So I need to change sum from n from 0 to n to 2. See? To infinity. And then for any n, I replace it with n minus 2. So here it's going to be n minus 2, a n minus 2, x to the n minus 2. See? If I want to shift it, x from 0 to x from infinity, or sorry, n from 0 to infinity, I can change it to n from 2 to infinity, and then I substitute n with n minus 2. Good. So in that case, I can write this summation as x to the n minus 2. Okay, and similarly, for this equation, for this summation, it would be sum n 0 to infinity a n x to the n. That would be sum n from 2 to infinity a n minus 2 x to the n minus 2. Okay, and then I write, I substitute this into that. Okay, so what I have would be summation n from 0 to infinity n minus 1 a n x to the n minus 2. Okay, plus summation n from 2 to infinity n minus 2 a n minus 2 x to the n minus 2, plus summation n from 2 to infinity a n minus 2 x to the n minus 2 equals 0. And guys, right now, we do have x to the n minus 2 here. There's no problem about that. Okay, they are all x to the n minus 2. But our problem is right now, our summation, they are different. See, one is from 0 to infinity, and the other two are from 2 to infinity. Okay, so we need to somehow change it so that they are the same. And that is very simple. That's very simple. How? Because if you look at the first summation, okay, can I write it as, when n equals 0 plus n equals 1 and then plus summation n from 2 to infinity. Right? From this property, guys. From this property. Okay, we know that, summation n from 0 to infinity, you can take, the first term out, the second term out, the third term out, until the term that you want, and then you continue with the summation. Okay, so in that case here, this one I can write it as, okay, let me highlight it a bit with the yellow color. Okay, to make sure that you know it's the same, guys. So it's gonna be 0. Okay, 0 times minus 1. Okay, but guys, I substitute n with 0. Okay, so here it's going to be 0 and 0 minus 1. That's gonna be 0 times minus 1. But guys, 0 times minus 1 is still 0, right? And then I get a 0 x to the minus 2 plus, and then again I substitute n with, here is when I substitute n with 0. Okay, and the other term, another term would be, I substitute n with 1, so I still get 0 as well, right? Because 1 minus 1 here would be 0. You will get 1 times 0, and that is still 0. And I get 0 a1 x to the minus 1. Okay, this is when I substitute n with 1. And then I continue with summation n from 2 to infinity, n minus 1 a n x to the n minus 2. And then, the other summation, they are the same, guys. Okay. Plus summation n from 0 to infinity a n minus 2 x to the n minus 2 equals 0. Okay, these three terms are from this. Okay, instead of going from n from 0, I take n0 here, n1 here, and then I continued from n equals 2. Okay, and these two guys are the same. I didn't do anything with it. Good. Is that good? Okay. After that, let me get the next page. So after that, we would have that. Okay, I'll group these summation together, because that's what we always wanted to do at the first place, right? We want to group these summations. That's why we change the exponents here, and then we change the summation here, because we want to group them, right? So right now we can group them. Why don't we, right? So I'll get 0 a0 x to the n minus 2 and plus 0 a1 x to the minus 1 plus summation n from 2 to infinity of, what is it, n minus 1 a n x to the n minus 2, right? Plus n minus 2. Okay, there's a big basket here. So n minus 2 a n minus 2 plus a n minus 2. Oops. There is x to the n minus 2. Okay. Plus a n minus 2 x to the n minus 2 equals 0. Okay. This is this. This is this. And this is this. Okay. Okay, I can group them together because they now have all the same exponents and they have the same summation sign. Okay, so after that I would write here as 0 a0 x to the n minus 2 x to the minus 2 plus 0 a1 x to the minus 1 plus summation n from 2 to infinity, and then guys, here I have n minus 1 a n x to the n minus 2 plus, guys, these terms I can get them together because they have the same a n minus 2 x to the n minus 2, right? So I would have, what is it, n minus 2 plus 1 a n minus 2 x to the n minus 2 equals, oops, sorry, oh, come on, where is it? X to the n minus 2 equals 0. Okay. And then I can pull x to the n minus 2 out. So I get 0 a0 x to the minus 2 plus 0 a1 x to the minus 1 plus summation n from 2 to infinity of, what is it, n minus 1 a n plus n minus 1 a n minus 2 x to the n minus 2, right, equals 0. Okay, and this is what we have. Okay, and guys, from this property, we know that where is it, here we know that summation a n x to the n equals 0, then all the coefficients need to be 0. Okay, if you have the sum equals 0, all the coefficients need to be 0. A n need to be 0 for all n. That means if you look here, you would have that 0 a0 equals 0. Okay, guys, it just say that if the summation is 0, the coefficient in front of x need to be 0. Okay, you don't memorize it at an. It might not be an. It basically says that all the coefficients of x are 0. Okay, so this is the sum equals 0. It means that all the coefficients of x are 0. So we have 0 a0 equals 0, and 0 a1 equals 0, and n minus 1 an. Okay, let me delete this parenthesis. Plus n minus 1 an minus 2 equals 0. Okay, that's how we get these three conditions. So from here, 0 a0 is 0. What does it mean? It just means that a0 can be any number, right? Because 0 times a0 is 0. It just means that a0 can be, any number. It's all right. Good. And similarly, 0 a1 is 0. It means that a1 can also be any number. Okay. And here we have the condition, and this condition is called recurrent condition. Okay, it's called recurrent relation. Here it's called recurrence relation. Recurrence relation. It means that you can find an by an minus 2. Okay, to write it more explicitly, I'll move this term to the right hand side, and then I'll move this to the right hand side as well. So what I have here would be an equals minus n minus 1 an minus 2 divided by n minus 1, and these cancel out. So we have that an is minus 1 over n minus 2. Okay, and this is why it's called recurrent relation, because you can find an from an minus 2. Okay, so right now we can write down all the coefficients a0, a1, a2, a3, a4, a5, blah blah blah. Okay, so right now a0 and a1 can be anything. So we're gonna start with a2. Okay, a0, a1, and then we need a2, right? A2 would be, what is it? Here, this condition holds when n is bigger or equal to 2, okay? Because a0 and a1 can be computed using this, condition, okay? Which means that a0 and a1 can be any numbers, okay? So n is bigger or equal to 2. What does that mean? Let's say a2 would be minus 1/2 a0, right? So we can write a2 in terms of a0. And again, a3 would be, what is it? Minus 1/3 a1. Okay, so we can write down a3 and in terms of a1. And then a4, that would be minus 1/4 a2. But a2 again, guys, a2 is minus 1/2 a0. So that would be, we can substitute this a2 with minus 1/2 a0. So what we have would be 1/8 a0. Okay, I just substitute a2 with minus 1/2 a0. So minus 1/2 times minus 1/4, that would be 1/8, right? And times a0. And the next one, I'll find a5. a5 that would be minus 1/5, a5 minus 2, that will be a3, right? But a3 is 1/3 a1, so I substitute a3 here with 1/3 a1. So what I have would be 1/15 a1. Okay, 1/15 a1. And when shall we stop? We're not gonna keep writing that forever, right? We're not gonna find a6, a7, a8, a9, a10, blah blah blah. No, we're not gonna do that. Okay, right now we know that a0 and a1 can be any numbers, right? Any numbers. And then we need to find at least 3 more a's in terms of a1. For example, in terms of a0. For example, here is in terms of a0, so we count 1. Here is in terms of a0 again, so we count 2. Okay, so we need at least 3 more terms in terms of a0 to answer. Okay, that is how you should answer. It's not actually what you should do in practice, but it's just what you should do in the exam. Okay, so you need to get at least 3 more a's in terms of a0 and at least 3 more a's in terms of a1. So now you have, this is the first one, this is the second one in terms of a1, right? So we need 2 more. Okay, we need 1 each. Okay, so we're gonna look at the case when n is 6. So we look at a6. That is going to be minus 1/6 a4, and minus 1/6 a4 is 1/8 a0, and that's going to be minus 1/48, right? 8 times 6, that is 48, and that will be minus 1/48 a0. Okay, so we already have 3 terms in terms of a0. Okay, and then a7, that would be minus 1/7, and a5, and that would be a5. What is a5? That's going to be 15 times 7, right? And that's going to be 105. So it's minus 1/105 a5. Okay, let me recap here. Okay, we get this condition, and that condition. Okay, so here 0 times a0 is 0. It means that a0 can be any numbers, right? So a0 and a1 can be any number, and we use this relationship to find other a's. Okay, we can use relationship to find a2, a3, a4, a5, a6, a7, blah blah blah. Okay, but you need to find at least 3 more terms in terms of a0 and 3 more terms in terms of a1. Okay, so this is the third term. Okay, guys, here is a1, not a5. Sorry, it's a typo. It's a1. Okay, so right now we can we have a2, a3, a4, a5, a6, a7, right? So we can write down the solution. And if you remember, at the beginning we assume that the solution can be written as y equals summation n from 0 to infinity a n x to the n, right? That is our assumption at the beginning. So here we would have that our solution y would be summation n from 0 to infinity a n x to the n, and that will be a0 x to the 0 plus a1x plus a2x squared plus a3x cubed plus a4x to the 4 plus blah blah blah. And then we substitute all the a's into the solution. So we have a0, x to the 0 is 1, right? It's 1. And then a1 x, a2 is minus 1/2 a0, right? X squared. a3 is minus 1/3 a1x cubed. a4 would be 1/8 a0. a5 would be 1 over 15 a1 x to the 5. Oh, sorry, I forget x to the 4. And then plus a6, that would be minus 1 over 48 a0 x to the 6. And then minus 1 over 105 a1 x to the 7 plus blah blah blah. Okay, and then we rearrange. Okay, we group the a0 terms together, and then we group the a1 terms together. Okay, we group the a0, the a1 terms together. Okay, in order to answer in the exam, you need at least 4 terms for a0, including the first one. Okay, you need the first one and another 3 terms, which means you need 4 terms, and you need 4 terms for a1 as well. Okay, so here it would be 1. Let me use the blue color. It 1 minus 1/2 a0, and then plus 1/8 x to the a0 squared plus 1/8 x to the 4, and then minus 1 over 48 x to the 6 plus blah blah blah. Here times a0. Okay, so basically I pull a0 out from these 4 terms. Okay, and then I have the x1 terms, right? That will be plus x minus 1/3 x cubed plus 1 over 15 x to the 5, and then minus 1 over 105 x to the 7 plus blah 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 times a1. Okay, and that is the solution. Okay, is that good? Cool. So let me recap what we have done in this such a long question. Okay, so first we look at the equation. Okay, look at the equation. We want to find the solution around x equals 0. So first we need to check whether or not x equals 0 is an ordinary point. Okay, that can be done by observing that b to x is 1. b to x is 1, which is not 0. It means that any point is an ordinary point, right? Or if you want it to be more specific, you can look at b2 of 0, and that is 1, which is not 0. So you can say that x equals 0 is an ordinary point. And when you say that, you have the solution in this form. And then you take y prime, you take y double prime, okay, and then you substitute that into or y prime, y double prime into the equation, and we get this equation. After that, we rearrange the terms, right? We change the exponent here, x to the n. We don't want it. We want it to be x to the n minus 2. So summation from n to from 0 to infinity, we can change it to 2 to infinity and substitute n with n minus 2. Okay, and similarly here, n0 to infinity, I can change it to n from 2 to infinity and substitute n with n minus 2. So after I change the exponents, I get x to the n minus 2, all are the same, right? And the remaining problem is the summation here is from 0 to infinity, from 2 to infinity, from 2 to infinity. So I split this into the case when n equals 0, n equals 1, and the rest I write that in terms of summation. Okay, and then these 3 summations are alike. They are pretty much the same, right? It's summation from n from 0 or from 2 to infinity, and you have x to the n minus 2. So you group them together, you get this, and that. Okay, and then you use the property that if the sum of anything, coefficient times x is 0, it means that the coefficient of x, they all need to be 0. And from here and here, you can say that a0 and a1 can be any constants. Okay, they are any constants. And from this, you can obtain an from an minus 2. And you can define all a's, right? a1, a2, a3, a4, a5, a6, blah, blah, blah. Using this recurrence relation. And then you write down the solution in this form. Okay, I forgot to write one line. I should write where a0 and a1 are constants. Okay, a0 and a1 are any constants. Good, and that is the solution. Okay, before we proceed to the next example, let me sum it up here, and that is the method. Okay, I have it here so that when you want to come back and revise for the exam, okay, you can just go back, come here to this slide to look at the method. Okay, and then you go to do the examples yourself. Okay, so the first step to find to find a solution around an ordinary point x equals 0. First, it needs to be ordinary x equals 0. Okay, that is a specific case. So you check if x equals 0 is an ordinary point. You can check that by look at b2x, b2 0, right? Whether or not it is 0. It shouldn't be 0, right? If it's not 0, it means that it's an ordinary point. If you forget that, go back to section 2. Okay, and write down the solution like that. Okay, and then you find y prime, y double prime, just what we have done, right? What we have just done. So, and then we substitute y prime, y double prime into the equation, the differential equation, right? And then we rearrange the exponents, the index, blah, 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 right? And then we set all the coefficients of x to zeros, okay? And then we can obtain a0, a1, usually we get a0 and a1. They are any constants. And then a3, a2, a3, a4, a5, a6, a7, you can write them down in terms of a0 and a1 using the recurrence relation. Okay, and then you can write down the solution, which is summation n from 0 to infinity, an x to the n. Okay, and in the exam, you need to write down at least 4 terms for a0 and 4 terms for a1, okay, to get the full mark. Good. Okay, let's look at another example. Next example, we want to find the solution around x equals 0 of the equation, this equation. So we first need to check if b2 0 is not 0. In other words, we want to check if x equals 0 is an ordinary point. Okay, so right now let me write b2x. It is 1 plus x squared. Okay, so b2 0 is 1 plus 0 squared, which is 1. Okay, that means x equals 0 is an ordinary point. Okay, because b2x is not 0, it means that x equals 0 is an ordinary point. So if x equals 0 is an ordinary point, so we can write down the solution in this form. It is going to be summation n from 0 to infinity an x to the n. And then again, guys, we write down y prime, which is summation n from 0 to infinity n x to the n minus 1. And y double prime would be sum n from 0 to infinity n minus 1 x to the n minus 2. Okay, so we can write down y prime, and y double prime. Okay, y prime, and y double prime. And then we substitute y prime, and y double prime in this equation. Okay, so what we have would be 1 plus x squared, 1 plus x squared, 1 plus x squared, y double prime, and that would be summation n from 0 to infinity n minus 1 an x to the n minus 2. Okay, and then plus 4 x plus 1 y prime, that will be sum n to 0 to infinity n x to the n minus 1, and then plus 2y, which is n from 0 to infinity an x to the n equals 0. Okay, after that I'll need to rearrange the terms, right? So here I'll write down this again as 1 plus 2x plus x squared, and then that will be sum n from 0 to infinity n minus 1 an x to the n minus 2, plus here it would be 4x sum n from 0 to infinity n an x to the n minus 1, plus 4 sum n from 0 to infinity n x to the n minus 1. You know that I just distribute that in there. Okay, so I get 4x, this guy, and 4 times 1, which is 4, and this guy. Okay, I get 4x, that guy, and 4 times 1, which is 4, and this guy. Okay, and then plus 2 sum n from 0 to infinity an x to the n equals 0. Okay, so what I have next would be, after that I'll just multiply this in there. Okay, so the first term I would have would be summation n from 0 to infinity n minus 1 an x to the n minus 2, plus 2, okay, 2 summation n from 0 to infinity n minus 1 an, and then guys we have x to the n minus 2 times x, so that will be x to the n minus 1, x to the n minus 1, and then we have plus summation n from 0 to infinity n minus 1 an x to the n, okay, x to the n. After that I would have plus, okay, begin with this term, okay, 4 summation n from 0 to infinity, okay, let me put the 4 inside, summation n from 0 to infinity 4 n x to the n. Does it make sense? Because I have x here, x times x to the n minus 1, that is x to the n. Okay, guys, just in case you get confused, this yellow part here, you get this yellow part here. Okay, and now this is the green part, and you get this, the green part. Next, what you have would be summation n from 0 to infinity 4n an x to the n minus 1, plus summation n from 0 to infinity 2an x to the n equals 0. Okay, after this I'll try to to group the x to the n minus 1 and x to the n minus 2 together. Okay, together. So the first term would be this guy, summation n from 0 to infinity n minus 1 an x to the n minus 2 is this term, so I leave it there. Okay, the next term, that will be n to the minus x to the n minus 1, so the next term I would have plus 2n n minus 1 an and plus 4 n an x to the n minus 1. Does it make sense? It's from this term and this term together, so we get this term. Okay, 2n n minus 1 an, 2n n minus 1 an, and then we have 4n an. See, and then we have x to the n minus 1, and that is what is it? We also have the x to the n term, right? So we get plus summation n from 0 to infinity n minus 1 an plus 2 an x. How about I pull an x to the n out, so I get plus 2 like that, and I get an x to the n. Okay, here similarly, I'll change it a bit. An, I'll pull this an out as well. Okay, so what I have would instead be an n minus 1, and that is 2 plus 4n, and then you get an x to the n minus 1. Okay. Oh, you still have a summation here as well. Good. Okay, after that, let me simplify it a little bit. Okay, so here it will be summation n from 0 to infinity n minus 1 an x to the n minus 2. Okay, plus summation n from 0 to infinity 2n squared, okay, minus 2n, that will be plus 2n. 2n squared minus 2n plus 4n, that will be 2n squared plus 2n an x to the n minus 1. Okay, and that is 2 plus summation n from 0 to infinity, and that will be n squared minus n plus 2 an x to the n. Okay, and this is what we have after simplification. Oh guys, I'm so sorry, I forgot one term here. We have x to the n is here, 1 term, 2 term, and 3 terms, right? So for x to the n, it need to be this term, which is from here, right? And then you need to plus 2, right? And then you plus 4n as well. Okay, I forgot the 4n, so I'll plus 4n as well. Okay, that will be n minus 1 plus 4n plus 2 an x to the n. Okay, my bad, sorry. And the next here, from here to here, that will be here, that will be n squared minus n, right? And minus n plus 4n, that will be plus 3n. Plus 3n. Okay, that will be plus 3n and an x to the n. So after this, we need to, again, guys, it's a pattern, you see. You just need to change the exponent here. See, it's x to the n minus 2, x to the n minus 1, x to the n, right? So if I want to change all of them to x to the n minus 2, so what I should do would be, here it would be summation n from 0 to infinity n minus 1 an x to the n minus 2. Okay, an x to the n minus 2. And then here I would plus summation n from 0. Okay guys, before I do that, can I factorize it first? So that you guys won't get it won't get too messy. Okay, to make you guys very confused. Okay, so I'll just factorize the n's first. Okay, to make it easier to look at. So here that will be 2n and n plus 1, an x to the n minus 1, and then plus summation n from 0 to infinity, and that would be n to 1 plus x an x to the n. Okay, that equals 0. I forgot to write. Okay, or equals 0. Okay, let me factorize it first, and then I'll get a new page. So after this, what we are going to do is to now change the exponent. Okay, change the exponent here. So this would be summation n from where is it, 0 to infinity, n minus 1 an x to the n minus 2, okay, plus summation. If we want to change from n minus 1 to n minus 2, here we need to start from n and infinity, and then we need to n from 1 to infinity, and we need to substitute n with n minus 1, right? So it's going to be 2n, it's going to be n minus 1, right? We substitute n with n minus 1, right? If we begin n equals k, we substitute n with n minus k. Okay, we substitute n with n minus k. So here it's going to be 2n minus 1 and times n minus 1 plus 1, that is going to be n, right? N minus 1 plus 1, that's going to be n. And x, an, it's going to be an minus 1. And x to the n minus 1, that is going to be x to the n minus 2. Okay. And the last term, we need to change from x to the n to x to the n minus 2, right? So we need to start from 2 to infinity, and that would be, we need to change n, again, n to n minus 2. Okay, if we change from 0 to n to 2, we need to change n to n minus 2. So here it's going to be n minus 1, right? N minus 2 plus 1, and n minus 2, n minus 1. And then n minus 2 plus 2, that is n. And an minus 2 x to the n minus 2 equals 0. Okay. And yeah, right now we have the same exponents, right? Which is x to the n minus 2. After that, we need to change the summation to be the same. And here you can see that it's summation from 2 to infinity, 1 to infinity, 0 to infinity. So we can split this guy. We can split this guy as well to make it to be summation from 2 to infinity. Okay, so the first guy here, it would be n is 0. If n is 0, the whole term is going to be 0, right? So we get 0, a0, x to the minus 2, right? X to the minus 2, n is 0. Plus, when n is 1, we're gonna get 0 as well, a1 x to the minus 1. Okay, and then when n is 2, we get 2 to infinity, n minus 1 an x to the n minus 2. Okay, and the next term, this term, we would plus when n is 1. When n is 1 is going to be 0, right? 1 minus 1 here, this term is going to be 0, which makes of this 0. So it's going to be 0, what is it? A0 x to the minus 2. Okay, plus summation n from 2 to infinity to n minus 1 n minus 1 x to the n minus 2. Okay, after that the last term, this term is going to be can I just write it here, plus summation n from 2 to infinity n minus 1 n and a n minus 2 x to the n minus 2 equals 0. Okay, so right now I can take these three summations together. Okay, so what I have would be here is 0 and 0 as well, right? I can group them together. So it would be 0 a n x to the n minus 2 plus 0 a 1 x to the minus 1. Sorry, 0 a 0. My bad. 0 a 0 x to the minus 2 plus 0 a 1 x to the minus 1 plus summation n from 2 to infinity, and then I get n minus 1 a n plus 2 n minus 1 n a n minus 1 plus n minus 1 n a n minus 2 and x to the n minus 2. And guys, this is nothing. It's this term, this term, this term. They are here, right, in the front. And then I take this summation, I group them together. Okay, so I get this coefficient here, this coefficient here, this coefficient here, and then I pull x to the n minus 2 out. Okay, and then we use the property that all the coefficients are 0, right? If the sum is 0, it means that all the coefficients of x are 0. So the first guy we have is 0 a 0 is 0 and 0 a 1 is 0. And this we already know that it means a 0 and a 1 can be any numbers, right? They can be any numbers, right? They can be any constants. Good. And then of course here it will give us a recurrence relation, right? So right now from this one I can write down an equals minus 2 n minus 1 n a n minus 1 minus n minus 1 n a n minus 2 divided by n minus 1. And as you can see here is cancel out, right? So we have that an is actually minus 2 an minus 1 minus an minus 2. Okay, minus 2 an minus 1 minus an minus 2 when n is greater or equal to 2. Okay, it's the same, guys. It's the same approach. See, it's the same steps, right? You just, first you look at the equation, right? You check whether or not x equals 0 is an ordinary point, and that's quite easy to check, right? After that, you write down y, which is the solution, and it's in terms of power series, right? Summation n from 0 to infinity a n x to the n, x prime y double prime, right? Oh, sorry, y prime y double prime. Put all of that back into the equation. Okay, and then you get, the whole long expression, and then you simplify it first, right? Simplify it a bit to make it look easy like that. Okay, it doesn't look very easy, but it looks easier. Okay, after that you see that the exponents of x, they aren't the same, so we're gonna change them to x to n minus 2. Okay, as you already learned, right? We change the higher exponents to the lower exponents. Okay, so if you have n minus 1 n minus 2, you change the n to n minus 2, change all to n minus 2, and that can be done by shifting the summation, right? Here it's the same, didn't do anything with it, right? This one instead of going from 0 to infinity, we go from 1 to infinity. But we need to substitute this n with n minus 1. This is what we did. Okay, that's how we can get x to the n minus 2. And the next one would be, to substitute n with n minus 2. That's why we get n minus 1 here, n here, and a n minus 2, x to the n minus 2. Okay, once we get, all the exponents are the same, after that we just need to somehow get the summation to be the same from 2 to infinity. So we can split this, when n here is when n is 0, n is 1, right? And then we take from n is 2 to infinity back to the summation. And similarly here, this is when n is 1, right? It starts from 1. So we start from 1. N equals 1, and then blah, blah, blah. From 2 to infinity, we get that to the summation. So these three summations are the same. We group them together, and that gives us the recurrence relation. Okay, and then we set all the coefficients to 0. That's why we can say that a0 and a1 can be anything, can be constants, right? And then we get an, which is in this form when n is greater or equal to 2. The next step, we would just need to write down all the a's, right? a0, a1, a2, a3, a4, a5, a6, a7, right? And those are just labor work, right? There's just labor work. It's just time consuming, but it's nothing hard. Okay, so let me write down all the a's. So I begin with a2, and a2 would be minus 2 a1 minus a0. Okay, that's minus 2a1 minus a0. And a3, what is that? It's gonna be minus 2a2 minus a1. Okay, but what is minus 2a2? Minus 2a2 is minus 2a1 minus a0 minus a1, and that is going to be 4a1 plus 2a2 minus a1. Guys, just be careful with these a's, okay, because it's quite easily to get it wrong. Okay, so just be extra careful with the calculation. Okay, so a2, substitute a2 here into this a2. Okay, I substitute a2 with 2 minus 2a1 minus a0. So I get 4a1 plus 2a0. See, I already got something wrong here. It's 2a0 minus a1, and that is going to be 3a1 plus a0. 3a1 plus 2a0. Okay, 3a1 plus 2a0. And a4 is going to be, what is it? a4 is going to be minus 2a3 minus a2, and minus 2 a3 would be 3a1 plus 2a0 minus a2, that will be minus 2a1 minus a0, and that is minus 6a1 minus 4a0 plus 2a1 plus a0, and that is minus 4a1 minus 3a0. Okay, so let me double check. Minus 2a3 minus a2, right? And then I substitute a3 with 3a1 plus 2a0. I substitute a2 with minus 2a1 minus a0. Okay. Okay, and then I distribute this in there, so I get minus 6a1 minus 4a0 plus 2a1 plus a0, and then I calculate this, I get minus 4a1 minus 3a0. And guys, right now it's enough. We already have 4 terms for A1 and 4 terms for A0, right? Because we have A0, any constant here, we have 1A0, 1A0, 1A0. So we already have 4 A0s, and we already have 4 A1 as well, 1 here, and 1 here. So it's enough. So you don't need to go for A5, A6, A7, okay? As long as you can get 4 terms for A0 and 4 terms for A1, that is done. Okay, so your solution y would be summation n from 0 to infinity a n x to the n. Okay, summation n from 0 to infinity a n x to the n. Okay, and that will be a0 x to the 0 plus a1x to the 1 plus a2x squared plus a3x cubed plus a4x to the 4 plus a5x to the 5 plus blah blah blah. Okay, and then that is a0x to the 0 again is 1 plus a1x plus a2 is minus 2a1 minus a0 x squared. Okay, here a2 is here. Okay, and then plus a3 would be 3a1 plus 2a0 x cubed. Okay, and then plus a4 that will be minus 4a1 minus 3a0 x to the 4 plus blah blah blah. Okay, and then I'll group a0 and a1 together. Okay, so this is the one. Well, let me write it down, to make it look a little easier. Here is a0 plus a1x minus 2a1 x squared minus a0 x squared plus 3a1 x cubed plus 2a0 x cubed minus 4a1 x fourth minus 3a0 x to the 4. Okay, and that is going to be 1 minus x squared. Okay, is from here, the first one, the second one, minus x squared, and the next one would be here, plus 2x cubed, and the last one would be this guy, which is minus 3x fourth plus blah 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 a0. Okay, and then plus here would be a1, which is from here. No, not a1, sorry, it would be x, which is from here, right? And then the next one would be minus 2x squared, which is from here, minus 2x squared, and then plus 3x cubed and minus 4x to the 4 plus blah blah blah, and then we get a1, and that is the solution where a0 and a1 are constants. Okay, so guys, try to do exercises, try to do them like many times. Okay, things will get clearer. Okay, it will clear up when you do more exercises. Actually, it's a simple step. You just need to first check if x equals 0 is an ordinary point, after you check that, you get the y solution in terms of summation. You take y prime, y double prime, you put all of them into the equation, right? After that, you try to make the exponents here equal, right? And if you have n minus 2, n minus 1, n, it's going to be equal at n minus 2, okay, at the smallest, okay, at n minus 2. And then you can do that by changing the index here, right? If you change from n from 0 to n to 1, you're going to need to change n to n minus 1, right? And that's how you change the index, so that you can change the exponents here. After that, you just change you just split the summation so that you have the same summations. Okay. After that, you use the property that when this is 0, all the coefficients of x are 0, and get this is 0 and that is 0. Okay, so when you have that, this is 0, it means that a0 and a1 can be any constants. Okay, when you have this 0, okay, you have that this is 0. So you can rearrange the term to get an in the recurrence relation. Okay, after that you can find a1, a2, a4, a5, blah blah blah, until you make sure that you get 4 terms for a0 and a1. For example, here you get, see, 1 term, 2 term, 3 term, 4 terms, see, plus blah blah blah. 1 term, 2 term, 3 term, 4 terms, see, plus blah blah blah. So if you get a0 and a1 for 4 terms, that is done, and that is the solution. Okay, guys, I'll let you guys do this yourself. Okay, this one. So you can try doing it yourself, okay, to find the solution around x equals 0 and to look at that solution. I can begin for you, right? This one, b2x is 1 plus 4x squared, right? So b20 is going to be 1 plus 0, which is 1. And it's not 0, which means that x equals 0 is an ordinary point. And then you can assume that y is summation n from 0 to infinity a n x to the n, and then blah 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 until you get the solution. Okay, so guys, I hope it's not too hard for you. Okay, this is the first case when we want to find the solution around an ordinary point x equals 0. Okay, in the next video we're going to be looking at the solution when around an ordinary point x equals a. Okay, for example, x equals 2, x equals 3, x equals 4, but not x equals 0. Okay, we're going to learn how to do that, and that is going to be section 3.2. Okay, and I think we have 2 to 3 more videos to go. Okay, so guys, try to do exercises and do the homework, do exercises, watch the videos. The exam is coming. The exam is very close, so guys, try to understand the materials. Okay, if you have any questions, you don't understand anything in the clip, just contact me. Okay, just text me, just tell me. Okay, don't hesitate, guys. Don't keep it to the last minute. Okay, I am willing to help you. Okay, I'm here to help. So let me know. Okay, if you have any questions, let me know. I am happy to help. I'm very happy to help. Okay, so see you guys. Bye bye.